Hello and welcome back to the Amped EV podcast. My name is David. I am the editor for The Buzz, and today we are talking about autonomous low-speed vehicles. These are really cool because think of them as people movers in a crowded space. They don't need a lane necessarily. They can kind of move wherever they need to go, and they're always looking at what's ahead of them. So to talk with us today, we are talking with Avinoam Barak. He is the CEO of Cartive. Let's get to the interview. Okay, Avinoam, thank you so much for joining us today. This is a really, really cool topic. So tell us a little bit about why EVs are such a good match for autonomous vehicles. Why are they such a good marriage together?
Okay, first of all, in autonomous vehicle, you must have many sensors and you need to have a computer inside, very strong computer, because you need to do a lot of calculation in order to avoid mistakes and so on. Those computers and sensor cannot be shut down when you close the car. They need to be in a standby mode. Because, for example, if you are waiting and the car is doing nothing, and now you want to order it, you need to wake it up immediately. So it needs to be in a standby mode. So it needs to have a strong battery and strong electrification in order to wake up very fast. Okay, it's not that I can use the gasoline in order to do it. So why? And the second one, and when you charge it, and suddenly there is an order, you can plug it out and send it immediately to the mission, which means that you need to cut off in the middle of charging. Okay. And it has to be controlled digitally. So it has to have power, which is electrification. This is one.
Sure.
The second one is that we need, in order to have a service all day around, we need to deal with it with a unique charging. Autonomous cars should be managed autonomously, their charging. There are a few methods we'll discuss later on of how to charge it. But we are not like in a normal autonomous vehicle. You charge it, not autonomous. You charge it for 10 hours and you have battery for us, we can charge it 20% because we need to give a service. So there is a lot of things or scenarios that can happen during the day that we need to control it and to cut it in the middle and then to continue later on and so on. And it has to be monitored digitally, control digitally, and be autonomously charging digitally.
Interesting.
So that's why we are fully binded and fully working only with electric vehicle and not any other vehicle.
Got it. Yeah, the autonomous charging, that's a really good point that I hadn't thought of. Can you tell us a little bit, just baseline about your company and the technology that you're using on the electrification and the autonomous side?
Yes. So first of all, we are working and specializing on low speed in managed area. This is the two critical parameters that we are expert, which means that our focus in this area. Now, when you are talking about low speed, okay, the stopping distance is very short. For example, a normal car, autonomous or not autonomous, electric or not electric, when you drive 60 miles per hour, your stopping distance is around 200 feet, 300 feet. Okay, not feet, yards, sorry. So it's like almost 1,000 feet, the stopping distance. When you are driving 10 miles per hour, your stopping distance is around 15 yards.
Wow.
Okay?
Yeah.
Which means that it's totally different game, which means that all the sensors needs to look for 30, 40 yards rather than few hundred meters and so on. And the safety out of it, it's much different because you have many pixels and enough resolution for any threat. When you see a person from 300 yards, for example, you have only few pixels and you have probability of mistake, which is quite high. When you see it from 30 yards, you have many more pixels on the person. So your probability is much higher. Okay, so this is the concept and the environment we have. The second one, if you are not working on a managed environment like normal road, then you have an autonomous vehicle, but most of the cars, 99.9, are normal cars with drivers. And they are making most of the problems. The drivers are making the problem. The drivers are creating the endless scenarios. So if you have a managed area, the manager of the area can decide who can enter, who can leave, and can decide about the rules in the area. Okay, so the technology we are using are perceptions, which means that we are making fusion of different type of sensors, which is LiDAR, radar, and camera. We don't believe of any sensor that can solve it. The only way to bring a really a working solution is by having uncorrelated sensors, few uncorrelated sensors. In the way that we are doing the control is different. We'll discuss it later on. Is different because we are managing the space and not the lanes. I will explain it later. And the navigation, comparing to normal electrical and not autonomous, should be very, very, very accurate. You know, in normal navigation, when you're using Google Maps and so on, so you can have 10 meter, 5 meter, 15 meter. I need to have 2 centimeters, 2 centimeter accuracy in order to drive. So we need to solve it. Later on, I will describe how we solve it, okay? And since we are working in a known area, in a managed area, we need to map the area in a very unique way. We need to have a really very accurate and unique smart mapping in order to map it, in order to work well.
And what kind of technology are you using to map that area where, to your point, you need to be able to know what is 2 centimeters in front of that vehicle?
Yes. So first of all, our navigation system is based on 2 centimeter accuracy, and the way to reach it is based on 4 different layers. Okay. And in the mapping, we are using the same car. We don't use any external devices in order to record the map. And we are mapping it in a 2D and 3D. Now, if you're asking about yourself how we are doing the navigation, one, we are doing normal GPS, okay, which is giving the 10, 20 meter accuracy. Second, we are doing a complementary solution by GPS RTK. RTK is a solution which is limited for a 10 miles diameter, okay, 10 miles circle, which is enough, you know, any area or hotel or anything like that, it's much, much smaller, okay? And in this case, we are like installing one navigation system in a specific known place, and it can send in the wireless system the corrections of the satellites, because we have one dynamic system, we have one static system, which we know the mistake in this static system because we really know the relocation. Because one, we know the relocation that we get all the satellites, and we know what type of mistake we have. So we send those mistakes, the corrections, in the network, and by that we get the 2 centimeter accuracy. But sometimes we don't have GPS. So we are adding 2 more layers when we find out that the GPS signal is not strong enough. One of them is the odometer. We count the number of the circles of the wheel, and by that we know exactly the size of the wheel, and we count it. So we know to complete it and to have a very good accuracy. And we have an INS system, like you have a phone with a gyro, but we have a very accurate one that we can measure all the acceleration in all axes and doing the integral mathematics one in order to find it. So we have 4 subsystems that just showing you that we are not relying on one, 4 of them that really bring us to 2 centimeter accuracy and loss signals of satellites for a short period of time.
Wow, very, very cool. Can you tell me a few use cases for using your autonomous low-speed vehicles? Where might we find them, especially here in the States?
First of all, we have one cart in the States, in Florida, but we haven't started any activity. We are now focused in Israel because, you know, we finished the development, but when you release a product, you have some problem at the beginning, and we want to have a good support, so we support nearby customers before we are going to the US. So the cart is manufactured by OEM in Turkey, and all the development is in Israel. So currently what we are doing is we are doing paid pilots by customers in Turkey and in Israel. We already shipped, our manufacturer is as a branch in Fort Myers in US, and therefore we have one cart over there, but currently we are focusing Israel and US. In few months, hopefully after we will have enough mileage with customers in this area, we will move to US.
Cool,
And
cool.
about use cases, you spoke about use cases. The use case we see our dream as the low hanging fruit combined with the vision. Okay, next step. So the low hanging fruit for us is resorts, is hospitals, is university campuses, is industrial campuses, is retirement villages, is gated community, is airports. Okay, many. For example, also car auction places that they need also all the way to go to the car, and then the car, but they want that the cart will go back autonomously. Otherwise, they need two drivers. So there are many type of applications.
Yeah.
Okay, even people are talking to us about putting in the zoo. We call it from US. One of the factory medical company in the US is opening a new facility, and they want it to be 40 carts going and giving a service. Some of it is a service not only to transfer people, but to transfer goods. Okay, for hospital, to transfer sheets and food between all the buildings, for example. So we have configuration with a box for logistic, and we have one configuration for people. So many applications. And one city in Arizona talked to us about helping drunk people to go from the parking to the place that they are drinking. Otherwise, they have a lot of accident. So really number of verticals are very high. But in the future, there is additional trend, an urban trend, which cities are closing their centers and not allowing. It's happening in Barcelona, it's happening in Paris, it's happening in Netherlands, it's happening in cul-de-sac in Arizona, for example. And they are closing the area, and they call it car-free zone. It doesn't mean that they do not need transportation, but there is bicycle and scooter. But they need transportation for the young people, small children with parents, and they need transport for the elderly people. So together, because this is not a small area, so they need some dedicated transportation. And we are aiming to solve this problem. It's still managed area, defined area, and so on. So this is our next step, because it will take time to evolve all the municipalities, because it takes time. It's a process, but this is the trend in the world. So we
Got it.
plan to be there as well.
Are there any applications in your mind where you could use the base of your technology, but you also utilize them on public roads, maybe for like a last mile delivery or a food delivery sort of service? Is that a possibility?
Yes, food delivery, we don't, this is not our focus. Although they can use it, but it's not the main application. And it's a big difference between what we do and versus food, because since we are taking people, the smoothness of the drive, it's very important. You cannot sit down in a car that is doing an immediate brakes or not slowing down before a traffic. That's what normal food could do, because we are dealing a lot about the smoothness, okay, and how much convenience and how to communicate with the person inside. This is all stuff. We'll talk about it later. It's not related to goods only. We can do goods, but the goods cannot do what, or those are doing the delivery cannot do what we do.
Sure.
Now, about last mile, what we are talking with municipality today is that the current solution is they can allocate it as a road. We are a very narrow car. We don't need more than 1.5 lanes of bicycles, okay, wide. And we can go for any dedicated road in the city. For example, in Tel Aviv, they are closing the Allenby Street, and they still want to dedicate a road, 1.5 meter for us, to go from both sides of the street to take people, because it's a long street. So people will come to Allenby by train or by parking, so we will be the last mile for their solution. Okay.
Very cool.
Later on, when the technology will be more mature and so on, we believe in park and ride solution, that we can support park and ride solution, and cover the last mile from train to office. But currently, as I say, we are starting with the low-hanging fruit, with resorts and so on, going to the urban car-free zone area, going to dedicated road in the city, and then for more open roads for last mile applications.
Got it.
But this is going to be, we are looking for simpler problem to solve today, and make it more complicated over time.
That makes a lot of sense. Yeah, that's probably the smart way to go about it. How about infrastructure challenges? You'd mentioned earlier using autonomous charging, for example. Are you having to install specialty charging stations to make that happen, or are you working with partners that have that capability to help make that work? Or kind of what are you looking at as far as challenges, and how are you addressing those?
First of all, about infrastructures, there are few infrastructure that we need, okay, that we need in order to operate. One of them is communication. Okay, we are not selling a car, one car. We are selling fleet of cars. So we have a site manager, which is totally different as opposed to a normal private car in the road. All the cars, our cars connected under one umbrella of site manager, okay, in the cloud. Now, this site manager need to have connection all the time, so communication is very important part for us. The second one, as I told you, is RTK, GPS, which is part of the infrastructure which we need to install on site. And the third one is the different type of charging that we need to develop. Now, regarding charging, I want to discuss it a bit more deeper. First of all, before we charge, we need to utilize the battery much better than others. I'll give you an example. If you, for example, are in resorts and you ask the car to come to you, and I have 5 cars available, which car do you think I will allocate to the mission? Okay, there is a site manager that decide which car to send. Which car? Normal people are saying the nearest one. Send it to the service. But I don't think that it's important that the nearest one will come. Why? Because we are speaking about managed area. The distances are not so far. So it can be 1 mile or 1.3 mile. This is not optimization. Okay, that we should do. So people will wait 1 more minute. Nothing will happen. Okay, and by the way, in our application, they know that it will come within 6 minutes and not 5. So we set expectation immediately. So our algorithm is based on load balancing. What does it mean, load balancing? I will select the nearest car as long as it has more than 50% battery. What does it mean? If, for example, the nearest car has 48% battery and the one car that is 200 meters far away has 84, I will select this car because I don't want to exhaust the one battery to get 20% and to send it in the middle of the day to charging.
Sure.
I want that all the fleet will be used in the same one. I don't want to have starvation. One card will not be used because it's a bit farther, and the other card will be overused. Because why? I will need to send it more to charging. And I will have less uptime of the system. So we start, first of all, optimize all the fleet before we charge. Okay, then we need to charge. And there are a few technology, as I mentioned before, which is mainly for electrification or electric vehicle. And we are doing some mix. First of all, one way that we are doing is we are managing the charging by assuming that there should be one person, at least in the organization, that manage the cards. For example, somebody needs to clean it. Somebody forgets some bag or forgot something in the car. So we need to call someone. So there is some central place in the organization that all the cards are coming. It makes sense that this central place will also have the charging stations. So first of all, without autonomous solution, when we want to charge it, we send the car to this station, and then we send an SMS to the owner of the station, please plug it in, and then another SMS, please plug it out. So first of all, we can do it, first of all, in a semi-autonomous way, okay? Because we are managing the process. But we are now working with few partners for wireless charging, which we are going to go above some surface that is wireless charging. There is another solution that is based on integrated on the roof, a solar panel, that will be charged all the day. We are now reaching some capacity that it start make sense. It costs a few $100, that's all, okay, for solar panel. Now, since we are managing in cards and we are normally working in good weather environment, Arizona, Florida, California, and so on. So normally there is enough solar energy available over there. And the last one, which is the most complicated one, in a very important area, we can insert the charging mechanism in the road. There is a company that is doing it, and during the drive, it's charging. So our priority is starting with semi-autonomous charging by SMS, as I told. The second one is the solar, the third, because it's the cheaper one. The third one is the wireless, and the fourth one, which is a lot of infrastructure required for that, is the one charging during the drive. So those are the way that we are dealing with infrastructure and charging.
Excellent. You'd mentioned the solar panels. Are those in place right now at this time, or is that something that you're working on?
We have a partner that is doing it. We are not expert on it, and we already have samples in our partners in Turkey, and we just need to decide that we are doing it. Currently, we support the semi-autonomous. We worked already with some charging, wireless charging, and now we are going to integrate with the solar panel. It's very simple. It's a good solution. The integration is the smart way here, not the product itself. The product is off the shelf, no risk. It's not but we are looking for the right capacity of the solar panel in order really to impact the service. Because what we really want is to have full day service without charging. Because today we found out that 30% of the fleet in average time is under charging. Because it's not managed.
Interesting. So I imagine the battery on these vehicles is quite a bit smaller than what you might find in a typical consumer vehicle that you're taking on public roads.
15 kilowatt hour, yes. But we are working with lithium battery. This is important. Our technology is based on lithium because we want to extend the life, and we don't want to have a lot of service during the period of service. We are selling it. We are not selling the cars. We are selling service. You don't need to pay us upfront money. You pay us a monthly fee that save you any cost of accidents, any cost of drivers, and so on and so forth. So you are paying us a monthly fee. So you don't need a real capital in order to start our journey. Okay.
Got it.
So it's important that the battery will be something that in the service will not cost us a lot of money to replace and give a service. So we are not saving in this matter.
And how does your team work with, let's say I own a company and I have, X amount of people visiting my facility every day. How do you help me determine how many of these carts I might need at my facility to, maximize ROI?
Very, very good question again. First of all, our concept is not to push. Don't tell you buy 70 and 50. Because you can go every week, you can add another one. The way to manage it is as follows. We add our site manager. In the site manager, there are 3 parameters that as an owner you see every day. 3 parameters. One of them is how many percentage of the fleet is available. You want 100%. Sometimes it's under construction, sometimes it's under maintenance and so on, but you want 100%. Okay? What is the level of usability? You want people to use it. So you define number of drives per day, and you want to see that they use it. And the last one is what is the average time in minutes that the people are waiting for service. Now, let's say that you bought 5 cards or 10 cards, and you see that people are waiting 15 minutes. So you need more cards, because you want to reduce. What is the service you want to give to your organization? You don't want people to wait 15 minutes. So you want 10 minutes, so you need to reduce. So everything is managed. You have the numbers, you could decide whatever you want.
Very nice. Well, Avinoam, thank you so much for your time here. I know I learned a lot. This is a really, really fascinating and interesting space when it comes to both autonomous vehicles and electric vehicles. So I just really appreciate your time, and I hope to have the opportunity to talk to you again in the future.
Thank you very much.
Okay, that was really cool. So autonomous low-speed vehicles, there's a lot to them. There's a lot you have to think about, especially when you have to see 2 centimeters in front of that vehicle to know what is in front of that vehicle at any given time. He's also talking about autonomous charging, which is a really, really interesting take. There's just a lot going on here. I can't wait to see these kinds of vehicles come to the States. Hopefully sometime soon. I guess we'll see. We won't have to see. Thanks for joining us. Have a good one.